Section 1.1 is expressions and variables. Our learning here, evaluate and write variable expressions. A numerical expression consists of numbers and operations. In the table on page 5, the expression 4 times 10 is a numerical expression. All it has is numbers and operations like times, divide, add, subtract. A variable is a letter used to represent one or more numbers. A variable expression consists of numbers, variables, and operations. So in order for it to be a variable expression, it has to have a variable in it. We can use algebraic expressions to generalize a pattern, just like with the table on page 5. The variable expression 4 times d represents the amount of food a blue whale can eat in d days. So to evaluate a variable expression, we substitute a number for each variable and evaluate the resulting numerical expression. In example 1, it wants us to evaluate the variable expression. Evaluate the expression 4 times d when d equals 120 to find out how many tons of food a blue whale eats in a feeding season of 120 days. So here I'm going to take my expression, 4 times d. I'm also going to take the fact that d equals 120, and I'm going to substitute 120 in for d. So instead of writing d, I'm going to write the 120. And that didn't change anything else. I still have 4, and I still have times. So then I actually multiply that out because that's my operation. And I get 480, and this is tons of food. And that's what I get when I simplify. In example 2, we're going to do the same thing here. We're going to evaluate the expression when x is 10 and y is 4 for both a and b. So I have x is 10. So everywhere I see an x, I'm going to write 10. And I have y is 4. So everywhere I see a y, I'm going to write a 4. I'm going to bring everything else down. So we didn't change the plus sign. 10 plus 4, 14. That's what we get when we evaluate that expression. Same thing on b. Here we have x, y. And remember, if we have two things back to back like that that are touching, it means they're multiplying. We don't see the multiplication, but we know it's there. So again, I have an x, which we said was 10. We have a y, which we said was 4. And we are multiplying them. So when we do that, 10 times 4 is 40. Checkpoint here, feel free to pause and give this a try. We want to evaluate the expressions when x equals 6 and y equals 12. So when x is 6, I'm going to plug in, when we see an x, I'm going to plug in a 6. When we see a y, I'm going to plug in a 12. So in number 1, we have y, and then no more variables, so I just bring down everything else, plus 8. And then, since all I have is a numerical expression, I can simplify 12 plus 8, 20. Give 2 a try. Here, I have, as far as variables go, an x, and we said x was 6, right here. And I don't have any more variables, so I can just bring down my numerical, my numbers and my operations, and turn it into a numerical expression. Now all I have is that numerical expression, so I can go ahead and do the operation here. 9 minus 6 is 3. And again, give 3 a try. I wrote down what x and y were equal here. Every time we see an x, we're going to put a 6. Every time we see a y, we're going to put a 12. So, first thing I see is y, 12. We have an x, 6. And we bring down our operation in between them, minus. Now that we have a numerical expression, we can simplify, and we just get 6. We can solve real-world problems by creating a verbal model and using it to write a variable expression. A verbal model describes a problem using words as labels and using math symbols to relate the words. There's a table on page 6 that shows common words and phrases that indicate mathematical operations. Like sum means add, of a lot of times means multiply, things like that. So check out the table on page 6, and that'll give you some help with what words mean which operations. example 3 here is writing a variable expression. You plan to divide the 120 players on a baseball league into teams with the same number of players. Use a verbal model to write a variable expression for the number of teams if you know the number of players on each team. So here we're looking for the number of teams if we know the number of players. And it says we're going to divide the number of players into teams with the same number of players. So we're going to start off with the number of players. Then it said divide, and we're looking for the number of teams. So we're going to, so this is the number of players in the league divided by the number of players on a team. And that'll tell us the number of teams. Okay, if we look back up, it says we want to divide the players in a league into teams with the same number of players. Okay, so we're going to take all the players in the league divided by how many players are on each team, and that'll tell us how many teams we have. There's a lot of different ways you can set up these verbal models depending on what you're trying to find. So if you set it up differently, it doesn't necessarily always mean it's wrong. It just means you used a different operation maybe, or we're looking for a different piece. So now we can write a variable expression. Okay, number of players in the league. So there's 120. Divided by number of players on the team. Do we know the answer to that? No. So I'm going to use x. And I'm going to say x is the number of players per team. Okay, make sure you define your variables. Otherwise, if you say 120 divided by x, we don't know what that x means. Is that the number of teams? Is that the number of players? Is it the number of days in a week? We don't know. Okay, so make sure you define that. And if you want to, you can go equals t for number of teams. But here they just wanted the variable expression. So the part we were really looking for is this. And that's all I have for section 1.1.